Hello, everyone. Welcome to the class. So far we already know what the memory hierarchy it is, and we already have a concept, an understanding of how to load the data from a low-level memory to a high-level memory, like registers, this memory hierarchy, right? So today we are going to talk about a concept called locality. This locality is highly related to this memory hierarchy model because of the loading, the copy of the data in this systems. So let's take a look of what the locality means here. So far we know in our memory hierarchy there's a couple different level, and CPU is the one we want to send the data into, and the CPU can do the computation, then get the result and store it in the memory, right? So there's a couple different memory uh, between your actual your memory to your physical memory to your CPU. There's a couple caches here, right? So if we cannot find a data in a registers, we will try to request it from the cache, and we will request it from the memory. And when we find it in the memory, it's load the data. So but you can see the CPU with the registers. The register part is very small compared to the bigger like memory space, like your disk or even the physical memory. So therefore, you cannot load all the data together. You cannot say, okay, I have 4 GB RAM, and I load all the data in these 4 GB to the registers because I want to use all of that. No, you cannot do it. So, which means when you load this data, therefore you need to pick some portion of the data you need, not just all the data. So if this is the truth, if this is true, which means there's some limitations when you load the data, right? Because of these limitations, we need to care the locality, how your data's locality in your program, because it will highly affect the performance of your program. Why? Imagine that I try to find the data, and this data already in the physical memory or is already in a cache. It's much faster than I load the data from the disk, right? So, which means if I can prepare as many as data I want, I need for this program into a physical memory, not just on the disk, or even further, if I can prepare all these data in registers, I don't need to change the registers data all the time, value all the time. I just try to kind of use a register to save the very important memory address, something like that, and I can reuse it again and again. I don't need to load the memory address from the physical memory, then load another memory address. If this is true, then we can make your program performance much better. So let's look at what's the locality here. Actually, when we talk about locality, this concept, there's a two category of locality. The first one is a temporal locality. So what's a temporal locality? This is an example. In this example, very simple example, just use a for loop. We have I equals 0, I less than n. I plus plus. We try to do the sum of this array, and you can see in the memory address, it look like this way. So array, when you initialize array put into your memory sequence, like consequentials in the memory space. So you have a memory 0, 4, 8, 12 for each data you have. So this is kind of the array contents, okay? So you can imagine that when we access this data, we will try this first because we do V0, right? Then we try the second one, V1, V2, V3, and so on. So we load this data one by one. So in this case, definitely every time we do load a different data, which means we cannot reuse the data again inside memory here, right? So why we still say this is a temporary locality, the reason is that imagine that we have index I, we have your memory address V. We have a couple of these kind of, we also have some this information. So these information, they are kind of be reused again, again, again. So which means what? Which means this data can be stored in the registers. You can use particular register, for example, EAX. Always remember the sum. You just keep put at the new information, new data in memory. Each memory data here, each data in right here, into these registers. You don't need to load a new data from the memory to registers, then do the sum. So it will save you like a couple loading time, copy time from your data from your to the data from your memory to registers. Also, index is the same one. You every time you increase the particular registers, for example, EBX, you just always use EBX to remember the I. So you keep use this data again, 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 use sum, use I, use the V array, and you can imagine like V array is like a memory address of the first element. So you can easily use this 04 as a shift offset, use as an offset to like put to this particular memory address. You don't need to change this memory address. You can store this memory address of the first element into a particular register like a ECX, right? So you can this whole bunch of this information like I, sum, and V, you reuse it again, again, again in at this moment. So in your when you run this program, in your assembly, you don't need to change your registers in this case because the registers can be used to remember the I, remember the sum, remember the V until you finish the loop, until you finish this loop, right? So it will save a lot of time. When you load, if you cannot find the data on register, you need to load it from cache. If you cannot find it in a cache, you need to load it from the memory, right? So if you try to do this loading, it will take some couple cycles to finish the loading, the data copy. So definitely, if you can keep this data in registers, it will like speed up your program a lot. So this is what we say temporary locality. Temporal locality, what does this mean? Means if your program, you try to reuse some variable, some instance again, 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 then you will have you just use it like at a particular time, like a slot, like a time frame, and you use it a lot. In this case, you have a good temporary locality for your program has a good temporary locality because it will get much faster than if you want to do it other way. Okay, so we call this is temporary locality, and this is a good example for temporary locality because we reuse this variable. Another concept of temporal locality versus the temporary locality is about the spatial locality. The spatial locality, uh, sometimes you cannot have both. Sometimes you need to think about a trade-off between these two. You want the temporal locality more or spatial locality more. But sometimes you can keep both. In this case, this is an example. We change the example from a 1D array to 2D array. So you can see inside this 2D array, we have m times n, and we because it's 2D array, we use two for double loop. And inside double loop, we still use a sum. So we just use a sum, try to add each value here, okay? So it's not so different, except this is the double array. So inside array, inside the memory, you can see this 2D array is stored in this way. You store the first row, the element in the first row, then you store uh, the second row data, okay? So if you understand this part, what's the spatial locality here? Spatial locality means how close your data to another data you want to access. So let's try to run this example. In this example, because we say j equals 0, j less than n, I equals 0, I less than n. So we try to do I equals 0, then I equal to 1. So you can imagine that the first element This is the first element we're trying to access. 0, 0. But next one, I change it to 1. So this is the second one we want to access. And you can see we do a jump here. So the shift is like a plus 12. Okay, so far there's no big issues. However, if you look at the next one, j become 1 and I become 0. So what happened? The third one will be this one. So in this case, what you can do is you need to do minus. You need to do minus a, right? And this minus a is not so consistent in this case. So because you have a 12, you have an a here. So it's not just like the previous example. You can just always go to next one, next one, next one, next one. You kind of jump back and forth. So what happened here? Imagine that your memory is like limited. If you try to store some data like this, first of all, you probably can, if your memory is so limited, you can only load the first three elements. In this case, you want to use the second one, you need to load the second one and get rid of first one. Then the next round, you want to load this one again, then get rid of the second one. So you can imagine that you need to do more load, like a loading in this case, if your memory is limited. Also, even though you can load every array here, you can see because you do the offset shift here, like a kind of like a not so consistent like a offset shift here. So your code in assembly will be more complicated. Not just every time you finish one, you increase a particular offset. You need to count the offset first, then do the assembly. You need to count the offset, maybe set into a register, use the registers to do this like a memory shift, right? So this is not a really good example for locality. Why? Because we do not access the data close to the previous data. So how to make this code a good example of a spatial locality? It's not so difficult. Actually, what we can do is we can try to change the order of these two lines. We make I equals 0, I less than n, and we put j equals 0, j less than n here. In this case, you will see is you access this one, then you access this one, then you access this one. So each data you access, compared to the previous data you access, each data you access is much closer to previous one. And the offset is getting consistent plus 4 here, right? So in this case, this is a good example of spatial locality. When you write the program, think about this locality a little, can speed up your program, can make your program perform better. Okay, so this is the concept of spatial locality. Actually, temporal locality, the concept of temporal locality is like do you like use the same variable or same instance again at the particular moment, uh, particular time step? Spatial locality is like, do you use the data close to like another one? Like, do you use this data close to each other? So if you use the data close to each other, then it's a good spatial locality, okay? So I hope you got this idea. This is for today. I hope you enjoy it. Today is a short video. We just talk about locality, this concept. Why? Because you can see in the memory hierarchies, because you have a couple copy the loading of the data from the memory space to another higher level memory space. If you can consider to put the locality, this concept, in when you develop your algorithm, make it a good temporal locality or a good spatial locality, then your program will perform much better than you don't do anything. Okay, so I hope you enjoyed today's video. See you next time. Locality is interesting.